Today we are going to understand the wildcards in generics. This is one of the most confusing topics. Let's try to understand this. So in wildcards, we say the type is unknown, and that unknown is denoted by this question mark. That is the wildcard. There are two types in this. One is upper bounded wildcards, which is represented by question mark extends T, any type, and the other one is lower bounded wildcards, which is denoted by question mark super T. We'll first cover the upper bounded wildcards. So what is this? So when we say upper bounded wildcards, it is basically a producer, or you could say something what we want to read. So let's understand this from an example. Say this is my list, and when I say question mark extends animal, right? So in this, the actual type can be dog, cat, lion, and any subtype of animal. So any subtype of animal is a valid type in this. So what compiler knows from this? Say this is an unknown type. So your compiler is not able to infer the data type. So for this, what compiler just knows that it can be any class which is a subclass of animal. So in this case, it could be that cat, dog, cat, lion, etc. So let's understand some key rules. You can read elements as type T. That is the upper bound. So what it means? Say I'm creating this kind of array list. Okay, your list is extends animal. So upper bounded animal. That means all the subtype of animal. And here I'm saying it's a list of dog. So when I'm reading the element, when I get it, so I can get it into animal. So this is allowed. This is the correct option here. And why the write is not allowed? So here list dot add is new dog. So it says compiler error. You know why? Because your compiler won't be able to understand or know which type of animal will be stored here or will be sent here. So that is why we get the compiler error. So it could be dog, it could be cat, it could be animal. Say suppose I create the list of dogs, but since we are saying any subtype of animal, right? Then if we send cat, and if you allow it, then we are actually storing cat in the list of dogs, which is not correct. Similarly, uh, we are storing animal here. Animal is basically it's dog is an animal, but animal is not a dog, right? Animal could be dog, cat, lion, etc. That is why this right is not allowed, and that is why in the upper bounded wildcards, rights are not allowed. So the same thing has been explained here. The actual list might be list of cat. Adding a dog to it would break type safety. Here we can see list extends animal, and actually it's a list of cat. But if I try to add dog, then this is not allowed. That is why we get this error, or the right is not allowed. Let's understand one more thing about the upper bounded wildcards. What happens basically when I say list of integer, you add list and say suppose near the method here public static void here, which is list of it. In this case, you can put like this object of list out. This is a valid method. Now let's try to in this list, and then it clearly shows list of integer. It's not matching, right? It is not able to. Ideally, we might end up thinking since integer is an object, right? Every class has the has object access currently. So in this way, we would end up thinking list of integer and list of object is same. It should work, but it doesn't work like that. This is not same. So that's the idea about this, and that is where the wildcards come into picture. So if I send, so if I just send a question mark, this is unbounded wildcards. So if I send this one, then it works fine. So now it can be any type. Okay, so this is the unbounded wildcards. Now coming to upper bounded wildcards, let's take this example. So when I'm saying upper bounded wildcards, just keep this in mind, extends keyword, and whatever you are basically producing or basically sending out, that is your upper bounded wildcard. In this case, it is working fine because your list of integer, when I say list of integer is a subclass of number. You can just do something like list dot add. Okay. If I do this, ideally I should like this is equal to read this properly. Now say if I try to add a floating point number, it won't allow, right? Because your list is defined as integer. Now let's create list of float. Just add float here. You print the float as well. So it allows any subtype of number is allowed in this case. That's the upper bounded wildcards. When we say upper bounded wildcards, just keep this in mind. Upper bounded wildcards equal to any subclass of T. Basically, if I say chemistry, in this case, any subclass of T is a valid thing. Okay. Now let's take one more example. I'll create let me close here. Just creating this class. Now we have animal. Now create that animal. Create okay. This is the hierarchy that we have. Now let's list of strings animal. When I'm saying this, it means any subclass of an animal is a valid or valid type. Okay. Here I'm not mentioning which type. I'm just mentioning any subtype of animal. Now, if I try to add here, it will not work. The reason being, The reason being, here the type is unknown. It doesn't know which subtype of animal. The list is which subtype of animal. See, anyway, your list will be of either dog or list of cat, something like this. But it cannot be a list which is having different kind of animals, right? And that is where compiler is confused, and compiler is not able to make the judgment whether this is a correct statement or not. That is why it doesn't allow anything to be added, but it will allow something to be read. Okay, let's try this out. If I do animal is equal to animal list dot get 0. This is a valid statement. This works fine. So if you do a get, basically it works fine because here it knows that it is whatever is a subtype is an animal. So this is a valid scenario. But what would be invalid here? Say suppose I make it a dog and I do this, then this becomes invalid. Why it becomes invalid? See, your list or compiler doesn't know whether this list is of list of dogs, list of cats, etc. Just a simple rule of inheritance. So in this case, you will have to do typecasting. Then it works. If you want to, but in generics, you want to avoid it, right? So that is where the lower bounded subtypes will come into picture. We'll cover that in time. For now, this is the upper bounded wildcards. A few points about the upper bounded wildcards. Let's understand that. The first is if you see extends, you see something like this. Extends T. It means any subtype of T. This is upper bounded wildcards. Then the second point, this is the producer basically. So generally, your return types or what goes out is your upper bounded wildcard. And the third point is only read operations allowed. Only read no writes. We have seen that, right? If we try to add anything here, we are getting error, the compilation error. This is about the upper bounded wildcards. Now let's move to lower bounded wildcards. In lower bounded wildcards, this is generally used for writes, or you could say it is a consumer. So basically, whatever goes into that is it is consumed. So that is where the lower bounded wildcard should be going to come into picture. So question mark superity. As soon as you see super, it means lower bounded wildcards. So what it means here, when we say super dog, so super of dog, any super of dog, that is any super class of dog. Say in our case, the super class of dog is animal, and animal super class is object, and any subtype of dog is also allowed. So just keep this in mind. But as we, as I said, right, with wildcards, it is not aware which one. That is the thing with the wildcards. It is still unknown type, but you have restricted, you have bounded whether it's a superclass of T or subclass of T. In subclass of T is upper bounded and super class is lower bounded. The key rules here, in lower bounded, you can write a question mark super dog. So in this case, I can add a dog right? I can dog Labrador also because it is a dog. Because here there is a surety, right? Labrador is a dog. If I add animal, it won't work, right? Because here compiler won't be able to understand animal because animal can be cats, lions, etc. Not only dogs. Same for object as well. So here the highest level which you can insert or write is this dog. Just keep this in mind. But it allows write. That is the advantage here. And in case of read, you can read only as an object because everything finally ends as object. So that is why you can read only as object. But if I try to read it as normal dog, then it won't work. Same for animal. See, when I say it's super class of dog, it could be animal, it could be object, it could be anything, any super class of dog. If I do a list of get and get it into dog D, here I'm not sure whether I'll get an animal, whether I'll get the object, and that is where the confusion is. Since compiler is unaware, is uncertain, that is why it gives compiler error. But object being the top of the hierarchy, it allows this one, the first statement. So that's the important part about the upper bounded wildcards. Let's understand this with an example. Here we did the lower bounded wildcards. Now let's understand the upper bounded wildcards. So I'll add to list. Here I'll say super integer. Let's start add 100. Let's start add 200. Since this is all integers, it works fine. Now suppose if I want to, I just wanted to convey here that we can write. But the same thing if I do here in the upper bounded wildcards, it won't work. You've already seen that. Here it gives error. It is not aware what would be the number type. It would be integer, float, whatever inside this method. If you look inside this block, here it is unaware. Compiler is unaware what it would get. Integer, number, float, etc. Even here, it knows that it's an integer. Till the time I'm adding integer, it is fine. So this is how the upper bounded. So this is lower, sorry. This is lower bounded wildcards. This is an example of upper bounded wildcards. We'll take this example only. Animals. If I do per of dog, I would say it's dog list. Here, in getting this as invalid. Why this is invalid? Because here, when I do a dog list and get 0, from this list, I will get superclass of dog. It could be animal, it could be object. So say, suppose it's a object. So here this will create a problem because object is the super type of animal. So on the left hand side, when you are assigning, we can have the super type, but super type of any class. Otherwise, we'll have to do the casting. Casting works, right? That's the problem here. But if I make this statement as object equals to, it allows. So this is a valid state because whatever you get, the highest superclass is object. That is valid. Now we'll try to add data in this list. Dog list dot add. Let's add new dog. It works here. If I try to add cat, it won't work because cat is not a superclass of dog. It is a subtype of animal. If I try to add animal, it won't work because here it is unaware, right? Animal could be dog, cats, anything. So you're breaking this rule that this is either a dog or a superclass of dog. Even though animal is a superclass, but then animal can have so many subtypes. Similarly for object as well. It won't work. But you can have dogs or its subtypes. Say I create Labrador, it extends dog. Now if I add Labrador, it works because Labrador is a dog. So just keep this in mind in case of lower bounded wildcards. So first is if you see something like this, any superclass of T or any subclass of T. These are valid. Write operations. Third is the consumer. So you consume it. Here you are consuming the data and not returning it. So that's the important point here. And consumer plus you could say what comes in. That's how you can relate actually. So what comes in this case you are able to write. Whatever comes in, you can write. That's the important distinction. Whatever comes in is a consumer. And that is your lower bounded wildcards. In that case, we should use lower bounded wildcards. Hopefully, you understand the difference between the upper bounded and the lower bounded wildcards. So, so now let's understand the difference between bounded types and the wildcards. What is the difference? Let's try and understand. When I say bounded, so we have already seen this. So these all cases where we are passing T and it extends comparable or something. These are bounded types. Here I'm bounding it. So here I can have number and comparable. Any class which is a subclass of number and it has implemented comparable interface. So this is how you can actually define in the bounded types. But if I go here, I cannot do multiple types here. It is not possible. You can have only one type which is mentioned. This is one example, one difference. The second part is bounded types. You generally see them in the classes, methods, parameters, something. But you cannot use it directly here. Like cannot write T extends number. Okay, right? Something like this. This is not valid. Unexpected one. This is not a valid statement. So inside a method block, you cannot use this kind of statements. So if you want to do something like this, then you have to use the wildcards. This is the another difference between the bounded types and the wildcards. So hopefully you would have understood what is upper bounded wildcards and the lower bounded wildcards. Just keep this in mind. Upper bounded wildcards, it means any subclass of T. That is any subclass of T extends. Any subclass which extends T. Any class which extends T is subclass. Producer means it returns the types or what goes out, whatever we are returning. So producer returning. It is you are reading out, reading out. You're not writing in. Just keep that in mind. So upper bounded wildcards don't allow any writes. And in case of lower bounded wildcards, it is any superclass of T or all T or any subclass of T. Write operations are allowed, but read are not allowed, except for objects. Except for objects, what we have seen there. And it is a consumer. Whatever comes in is the upper bounded wildcards. So if you have seen the example of comparator, the collections dot shortlets, just open this method. Here you can see, here there is a list of T. Say it is a list of string, or you can say list of number or integer. So when I say integer, comparator, super integer. So any superclass of integer is allowed for comparison. So this is the consumer part. That is why this is lower bounded wildcard. Just keep this in mind. Because if we use extends here, the problem is, say if I use extends integer or extends number. So number can be integer, float, double, long, etc. So if we do comparison between integer and float is not correct, right? So that is why we have to use super here, lower bounded wildcards. This is one of the examples, the real-time examples that Java is implemented. With this, I'll end this lecture. Thank you so much. If you have any doubts or something, you can comment. This is a very confusing topic, but still I would say that you can go through this and you'll be able to understand it. Thank you so much.